So in the previous session, we were discussing about volumes, physical volume and physical volume claim, and we created physical volume manually, and we created physical volume claim, and also we created a pod which is using the PVC so that we can able to access the storage. So let us go through once again, and then we discuss about how dynamically we can create physical volumes. So we were creating physical volumes through static way, right? So we have another option, dynamic way, how we can create it. So this is what we discussed yesterday. So physical volumes gets created. This is also same like this worker node. Worker node is going to provide you CPU and RAM for the pod, and storage physical volume will provide storage to the pod. So with the help of this PV, we can create PVC, and that PVC can be added inside the pod definition file, whether it can be deployment definition or maybe stateful set. It depends. Okay. So we have seen statically how we can create this PV, and how we can create PVC from this PV. Also, we discussed mm, if you use 100 GB PV, and if you are trying to create 50 GB PVC, then it is going to take this 100 GB PV. Okay, so it means if it will check if you have multiple PVs available, and when you're trying to create PVC, then whichever is suitable for that PVC, it will take the respective PV. If you have 100 GB, 80 GB, 60 GB PVs, and we are trying to create 50 GB PV, it will take 60 GB PV. Okay, so statically we were creating, and yesterday we were in middle of that. So let me log into that server. Okay, kubectl get PV. This was the PV which we created, and kubectl get pods. You see, this is the pod which is running, and kubectl get PVC. Okay, so this is a PVC, and this is a PV. So this PV was using this PVC. What we have done, first we created PV, and then we have created PVC, and then that PVC we were using inside the pod. Okay, so now you see here, this is an pod. Where is the pod? And this is a pod which is using the busy box, and inside that it is using this. If you want to see kubectl describe pod, and you can use busy box pod name. And here if you see volume section, so this is a describe command to see detailed information about this. And if you see here volume section, it's a persistent volume claim it is using, and this is the PVC it is using. Okay, so with the help of this PV, it is mounted inside this. Okay, and if you see my data, it has been mounted, so it can be used. So but we were using this as an host path, right? So already yesterday we have seen kubectl get pv. Okay, so like you can see pv and pvcs by giving the comma, no need to execute two separate commands, and this is the pv and these are the pvcs. Okay, so here we discussed pv. So this pv is bounded with bound, and this is bounded with this specific pvc. So in the pvc configuration, you are not specifying to go and contact or bind with which pv. Automatically it will take. Okay, and we already discussed reclaim policy like retain, recycle, delete option. So by default it will be the retain, and access modes also you can give what kind of access modes you are giving and the size. So we discussed the files, the physical volume creation, and PVC creation and busy box creation, right? I think, not what was the directory we created yesterday? I think storage. Yes. So these are the three files. One is for creating PV, and then PVC, and then BusyBox. Now we'll talk about dynamically how we can provision the physical volumes. I am not going to create physical volume first. Why? Because I don't know, like for example, if I create 100 GB, then maybe the requirement is 50 GB, then it will take the 100 GB physical volume per PVC. So instead of that, whenever PVC gets created, at that time PV also should get created. So that whatever the size we are expecting per PVC, that with that size only the PV gets created. So for this we have one of the option. Okay. So one of the option called as NFS dynamic provisioner. Hmm. So how many of you know about NFS?
NFS volume?
What is NFS?
File sharing.
Network file share.
Yep. So is everyone aware about that? If no, then please let me know. Then I will explain you little bit in detail what is exactly NFS. If you guys know, then I'll skip introduction of that NFS.
It's better to explain.
Okay. So NFS here, to talk about NFS, it's not those who don't know. Maybe here in this batch, a lot of people has been joined. Maybe those who listen the recording. Okay. So they might also not aware about, some people might not aware about NFS. So NFS is not belongs to either cloud or not, it's not belongs to only Kubernetes topic. NFS is available since many years. Okay, before cloud has been introduced, it was using in the Linux environment. Okay, when the data centers was there, the companies used to have hundreds of servers, whether it's a virtual machines or physical machines. From that time onwards, this NFS concept is available. It's not belongs to any cloud, or this topic is not belongs to specifically Kubernetes. That old topic NFS we are using inside the cloud and Kubernetes now, as of now. So what is this NFS? Network file service. Okay. So what does it mean? Network file service means, let me explain in a simple way. Let's say in our office, when I was going in a night shift, okay, we used to get lot of time. This is, I think, maybe 7 years ago. So we used to have a lot of time. So we used to watch movies, okay, because we were in support. So whenever we ticket comes, we need to work. So during that free time, we used to watch movies. So whoever working in the night shift, what we used to do, we used to collect all the movies, whether it's in a regional film or maybe national film or English. Okay. So all the collections, if I get any film downloaded from internet like that, so where we need to keep, let's say overall it became 200 GB. Now, if 10 people we are friends in that night shift and we want to watch movies, then what should be there? We need to have the 200 GB in each and every member's laptop or desktop wherever we are working. So in each and every person's laptop, it's 200 GB is there. Then from all the 10 people's laptop, it occupied 200 GB for everyone laptop. We are wasting the storage, right? So instead of that, what we can do, we can take one machine, okay, okay, let's say my machine, my laptop. There I'll create a directory and I'll put all this 200 GB content over there, and then I'm going to share it. Even in our Windows machine also, we can share the content, right? So if you right click the directory, sharing option will be there. So if you share that, then no need to download that content for all of them. If they know my IP, just they'll go here, run. Okay, so here they'll give just my IP address and what is the directory I shared. That directory if I give, then I can able to access that. So remaining guys, whenever they want to watch movies, they can able to access through the network and they can able to see. So they no need to install. Then you need to download all this content in their local desktop or laptop in the office. So this way they are saving 200 GB space, right? And whoever now collecting the information, they will same way they will access in this way and they will copy that content. Okay. So I mean this means in the one central location we are copying the data, the copying the movies, and whoever want in the floor we are able to access it and we can watch the movies. So this way we are saving lot of storage. So same way NFS is also same thing. I want some data should be available here some machines. Okay. So instead of creating a file system here, file system means whether in Windows D drive, E drive, what are the file system you use, NTFS or FAT32. In Linux also we have ext4, XFS, ext3 line file systems will be there. So you need to create a file system, means with 100 GB, 200 GB file system you need to create, and the data should be copied inside this one. So why we are wasting unnecessary storage? Because in real time storage is very costly because it's an SSD drives we are using, and storage team allocating 100 GB, 100 GB, 100 GB means it will almost 300, 500, maybe 1 TB of storage we are wasting. So instead of that, so we'll create one machine here. This is called as an NFS, and this NFS server we are going to share the directory. Let's say data directory is there. Here all that content is there, and this I'm going to share it to these three machines. So how I'm going to share? I'm going to give these machines IPs in the NFS configuration file. So NFS configuration file is, this is the configuration file. So here I'm going to give the IP address. Okay, and I can decide whether it's a read write or a read only option, and some more configuration is there. We are not going deeper inside the NFS topic now, just to understand what exactly NFS is. So we can give IP and we can give access, okay, to these machines. Once it is done, then how these machines know that we have an NFS share? You need to mount it. Okay, you need to mount this NFS share inside these machines. So further we use mount command, mount -t, which file system it is. NFS is one of the file system, like FAT32, NTFS in Windows and Linux. This is also one of the file system. NFS, network file system, network file service we can call, and the IP address of your NFS server. Let's say this is NFS server, and the whatever it is sharing, and in local in this machine where you want to mount it, maybe data one. So what it will happen? It will create a file system in this machine. This is a network file system. Okay, through network you are getting this file system. Generally, file system means what? Locally you will create, right? Locally you will create whenever the server down, whenever the server up, you can able to access that. But this is coming through this network. This file system is mounting here. Okay, so if the server goes down, you cannot able to access this mount point over here. So this way, this can be mounted in this machine so that this data can be accessed on these machines. Maybe that application is expecting some data, some information, which is mounted through this network file system so that it can be accessed. Okay. So this is how we use network file system. Through network, you are mounting a file system to machines. This is the concept of NFS. Now this concept we are using in the Kubernetes for dynamic NFS provisioner. Okay. So not only for dynamic, okay, just now, yesterday also we have discussed, right, this PV when we are creating, I have used which concept? Host path, right? So if you see here, cat PV hyphen host path. So here I was using host path, okay. So this is host path. Instead of this, we can use NFS also manually, even in static also, you can use NFS. The advantage is local host path means what it is doing here, it is creating a directory called whatever the name we are giving. With that, it's creating a volume PV, it's creating. So it's not good, because if this worker node goes down, then data is not going to sync here. But if you have your storage externally from your cluster, then it can be accessed anywhere. Even the pod is getting created here, no need to worry, because storage is available external of your cluster. So what you can do, you can create NFS here, and this NFS, from here you can create a PV, and this PV you can create PVC, and you can give it to the pod. So from external you are getting the storage. So even pod got deleted here, if it is getting created here, no need to worry, because the data is still available in the external world. External means not in your Kubernetes cluster. I was using host path. So even in static environment also you can use this server, NFS server. Okay. So now this NFS concept we are using in the dynamic provisioner, how we can use it. Okay. So now how we are using this in the cluster. So if this is our cluster environment, maybe, and these are our assume worker nodes. Okay. Now this is master and worker node 1, worker node 2, worker node 3. Now what we are going to do here, out of this cluster, I'm going to create one more virtual machine in AWS environment, wherever you're practicing. If it is an Azure or if it is an GCP, then there is another virtual machine. Or if you have both in your environment, you have on-premises data center and cloud, and both are able to communicate with VPN. Okay, then it can be in a separate your on-premises machine also. There should be network connectivity. Whether it's in the cloud or out of the cloud, it doesn't matter. There should be a communication between this cluster and this machine. Okay. So now this is an NFS server. So here what I'm going to do, NFS server, I'm going to configure same way. By default in the Red Hat Linux, or maybe all the Linux flavors, most of the Linux flavors, we are going to get NFS package by default. We no need to install this NFS package. Previously we used to install NFS package. Now we no need to install it. By default it will be available, but only we need to check whether that service is on or not. If it is not on, then we need to make sure it is started. Okay. Once it is done, then create some directory. Okay. So create some directory, something like this, any directory. It's up to you. You can create any directory. So now, where is this created? That is also matters. Assume if it is an AWS environment, so whatever this directory you are getting in real time, don't create this in the slash file system. Why? Because slash is having 8 GB. It's belong to operating system. If something happens to operating system, then whatever the volumes you are creating from here, that will be also corrupted. So instead of that, allocate new volumes. Okay. If it is an AWS, then allocate, let's say 100 GB volume separately apart from OS. And with that volume, you can create separate file system, separate drive. In Windows, we call D drive, E drive. Same way in Linux also we call file system. Separate file system, and that file system, this is the one. Assume this is a file system. And then you share this one, okay, in etc export. It's very simple, 3 commands in etc export. We will add this path and we'll give to whom we are giving access. Okay, so now after doing that, just we can check show mount hyphen e. Okay, then it will show whether it's mounted or not. And after that, what I'm going to do, when here in the cluster, I'm going to deploy some Helm chart. Not only Helm chart, we can use individual files also. So what it will do, it will call as an NFS provisioner. So this deployment I need to do. Okay. So while doing this deployment, inside this configuration file, I will give this is my NFS server. So that what it will do, it will create one pod. Assume it created here. So this is called NFS. This pod is called NFS client provisioner. Means this pod will act like a gateway to your other application pods. So whenever you are deploying any pods, application pods, which is expecting a PVC or PV, then this will help you to create a physical volume claim and physical volume automatically. In Prometheus, I will show you, because Prometheus needs a physical volume and PVC. I am not going to create either PVC or PV. So Prometheus, whenever I'm deploying it, automatically it will get created PVC, because this NFS client provisioner will help to create PVC and PV. How it will work, that I will show you in the Prometheus class. Okay. As of now, I'll in today's practical only the PV gets created automatically when I create PVC. But in real time, when I'm creating application, my PVC also should created and PV also should be created. I'm not going to create. Only I will give the name of this storage class. Yesterday I discussed storage class. So which storage class you are using? If this is NFS storage class, I will show you those. So here we need to do, we need to create 3 um, components. Okay, one is deployment.yaml, one is RBAC, and one is storage class. One is for deploying your NFS client provisioner, and second one is RBAC, role based access control. So let me show you. Basically, to get this NFS client provisioner, we have Helm chart also. Means we have discussed in the Helm the stable repository, which are providing some predefined Helm charts. For this NFS client provisioner also, they are providing. From that, I copied only specifically some files. Okay. So now Helm charts. NFS client provisioner. So if you see, this is the first one, NFS client provisioner. Now, if you go inside the templates, okay, if you see here deployment, this is a deployment.yaml file. Okay, so which is configured with all the if conditions, and it will be available in the what we say values.yaml file. So this is storage class, and these all are getting created. If you see here, So now what I'm going to do, I copied only few files from that and I modified accordingly so that easily we can understood. GitHub. And inside the docs. So NFS-deployment. So if you check this NFS-deployment, this is a kind is deployment. This is just a name. I am providing this for this deployment. And if you see here, this is the image it is taking. So this contains NFS configuration. This image contains NFS configuration. And here, what it is doing, here we need to give NFS server details. Means wherever you are creating this NFS server, this machine IP. This machine IP you are giving inside this configuration. And path. What is the path you are configured here? Okay. So whatever the path you are trying to share, that path you need to give it here. Okay. And this is creating like a volume. So same here also you need to give NFS server IP and the path. So this is taking as a volume from the NFS server and it is mounting inside the pod. This one. Okay. So this will help you to create PVCs for your applications. So this NFS client provisioner pod gets, so first what it will do, first it will get mounted here. This one will be get mounted inside this pod. This shared directory will be mounted here. And from here, this NFS client provisioner will help you to use this mount point to mount it in the pods. Okay, if this is expecting PVC, that will be get created from here. Okay, and logically you can go and see here, means physically it will be available here, the data will be storing here. And if you create one PVC in this directory, it will create one directory that contains belongs to one physical volume. If you create another pod and with another PVC, and that will also get created here, content here, and here it is coming from this machine. So here it gets created. We'll see practically how we can do that. Okay, so this is mounting here in the NFS client provisioner, and this is helping by using this storage, it is helping to create file system. Suppose I'm using this 100 GB and this 100 GB is mounted here, and it is, let's say this is 10 GB and this is 10 GB has been created and attached to the pod. One request was there 120 GB. Can NFS client provisioner can able to create it? Yes, it can able to create it. Okay, it will create it. But if really 100 GB data is filling, then it cannot able to fill the data because backend the volume is only 100 GB. This will getting full, right? So initially it will be empty, so that's why it will get created. When the data is filling up, then it cannot able to fill that data. But it will not give you an error that we don't have sufficient space. Okay, so this way it is going to work. So now here we are giving NFS. So the what are the pod is getting created, NFS client provisioner pod. Inside that pod, the NFS server volume is going to mount. Okay, so whatever the capacity you are giving, backend you can take the backup of this volume so that the data will be available. This is how it will work. And after this deployment, two more files we need to execute. One is this one, rback.yaml. What is this rback? You can name it anything. For easy understanding purpose, I provided rback, role-based access control. This is like sudo permissions in the Linux operating system. Let's say for application users, we don't give full access to the OS. We give specific access, means some commands we are going to give access to start their application. So if you want to give some level of access, then we'll add into the sudoers file what are the commands they can execute as a normal user, which they cannot able to execute by default, but we'll provide access to execute some commands, not full. And we can give full access also. If you want, we can give in the sudoers file, if you mention all, then it will be accessed by that user, everything he can able to access. Same way in the cluster also, we are going to give access to users or specific service to use only some portion of the Kubernetes cluster. That is with the help of this role based access control. We have separate session for this completely. Okay, so for that we are going to create a role, and for that role we are going to apply rules here. If you see here, so we are just giving access only to the volumes related stuff, not everything on the cluster. So cluster role, if you see, it is getting created, and cluster binding. So these are related to the role binding, cluster role binding, role and role binding. These are the four topics we are going to discuss separately. Okay, so this is role based access. So for us here, for our NFS provisioner, we are not giving complete access, because whenever the pod is getting created, this NFS client provisioner should have authority to create PV and PVC, right? Automatically it is creating, so it should have access to the cluster, and its responsibility to only have the PV and PVC, the storage related stuff. Apart from that, it doesn't require any other access to the Kubernetes cluster. So that's why these roles defined only to access the storage related stuff, storage class, storage annotations. Okay, volumes, get, list, watch, update, only about this, and volumes, resources, persistent volumes, and get, watch, create, delete, only related to the volumes. Okay, we are giving permissions. And the third file is the storage class, which is very important, class.yaml. So go here, if you see, this is a name. Okay, so managed -nfs storage, this is the name we are giving, because this is, if it is not, if it is AWS, yesterday I shown you, the storage class will be different annotation we are going to use. And if it is AKS, different annotation. Here main annotation is important. So here this is a default class. True means what? So this is a default one. So managed NFS service name, you can give any name here. So this is the storage class. Okay, so provisioner, if you see, this is the NFS, is the provisioner, we are telling that, so that it can accept. So storage class is also very important while creating volumes, because it should know, your cluster should know who is the provisioner for creating physical volumes and physical volume claims. See, physical, once you create physical volume, from that physical volume you can get physical volume claims, but from where this physical volumes should get created, that will be decided the provisioner. Okay, the storage class. If this is not correct, then you are not going to create volumes properly, physical volumes. It will show in pending state. So we need to create these three. So I need to copy locally these three. Okay. So what I'm going to do, already this has been implemented previously. So let me delete all of them. If you see kubectl get pods, if you see here NFS client provisioner, this is already provisioned. So NFS hyphen, inside this were the files. So what I'm going to do, kubectl delete -f nfs -f rback -f class. Like we can give multiple files in a single command. So whatever the resources was got created from these files, everything gets deleted. Okay, now if you see kubectl get pods, that NFS client provisioner is getting deleted. So I'm not going to copy these files from my GitHub. So already these files are available. So, but I need to configure NFS server first. So this server first, I need to configure. Where it is? This is the one. Okay. So for that, I need to have one Linux machine. I have many Linux machines in my AWS account. So let me use any of that machine. I need to delete unnecessary machines. Unnecessary, I'm getting bill. I'm not sure how much bill I got for this month. Now I need to take one machine. Let me see which machine I need to power on. Any machine, all are the Linux machines only. So this Tomcat server previously I was using as a NFS server. Let me take this one. I don't know what is this server. Okay, this machine is powered on. Now let me log into this machine. What happened? What is the key for this one? Q batch. Okay, this is Ubuntu machine. I don't want Ubuntu. Let me use this Docker. Okay, so this is a machine. So let me log into this machine. Then key is separate for this one.
So it's
Key is
working
the
only
Docker.
Linux machine.
Yes, NFS will work only for Linux machine.
Okay.
For Windows, you have Samba shares. Same concept, Samba shares for Windows. From Windows to Linux, if you want to mount, you have a CIFS file system. If you have a Windows server, from Windows server you want to share something to a Linux server, then you need to configure CIFS.
Okay, Priyan.
And Windows to Windows, you can use Samba. Okay, so by default, NFS package will be available. You can check with the RPM command. Okay, NFS package will be available. Only thing is, you need to check whether NFS is running or not. It is not running. So you need to start it and make sure it's power on. The service will be on during the server reboots also. For that purpose, you need to execute this command chk config nfs on. So this will become online when the server boots also. Otherwise, service will go down whenever server reboots. So again, manually you need to start it. If the service is down, then nfs share disconnect. Okay. So once it is done, it's very simple. So go to the vi etc exports file. Okay. Here inside it will be empty file. You can give multiple shares to multiple different hosts. So configure nfs client provisioner Kubernetes. Hmm, hmm. Okay. So this way you can create a directory. If you want whatever the directory you want, you can create and just give the permissions. You can give full permissions also. And then the share that directory in the NFS path. Okay, this is the path and this is the directory, what are the directory we created. And your star means what? It's an basically IPs. Okay, in this scenario, like we were talking about the traditional data center, there we used to give the IPs where you want to mount. But here we don't know the IP of this worker nodes, right? Worker nodes can be created and new worker node might be created. We don't know where is this NFS client provider is going to mount it. Okay, so if it is mounting here, then it will use this worker node IP. If it is mounting here, it will use this worker node IP. So and new worker nodes also might be created. So manually I cannot enter this worker node IPs inside the exports file. That's why we can use star. So anywhere it can go and mount it. Okay, means all IPs. And then just restart the NFS service. These are not required. And that's it. Okay, NFS is ready. Then I need to execute these three files in the cluster. But before that, I need to use the NFS server IP address inside this deployment.yaml file. And what is the path I need to use inside this volume of this deployment.yaml file. So here, before that, so here I am not creating any new volume and from AWS to create a new file system here. When I type dffnh, I have only one file system here, that is slash. Oh my god, it's already 100% usage. This I cannot use it. Why it is not deleting RM? Instead of creating this, let me take another machine, or I need to create new machine. Let me take Nexus. So let me log into this machine and see whether we can able to create it. Let me see the key batch. Okay. I log into the another machine. So service NFS status start chk config NFS on. That's it. Now make directory NFS share. This is a directory I'm giving, or else NFS client provisioner. This is a directory chmod -r NFS share. Sorry. Giving full permission. Okay. And now this information I need to this directory. See, this directory I created as a normal directory where it got created under the slash. So slash is having only 8 GB. As I said, create a new volume, attach it to your machine, this machine, and create a new file system. Okay, new file system means new drive. Okay, like D drive, E drive. Create new drive and use that directory for your volumes. Okay, so here now vi etc exports, it will be empty by default, and this way. These are the NFS options. Okay, and NFS client provisioner. This is a directory. Star means for everyone. Okay, so cat etc exports. Just I want to confirm whether I created, mention the, okay, I did not provide correct directory, so let me modify once again. Okay, so it has been provided. Now export fs -ra, sorry, vr provided correct only, right? Show mount -e show mount -e, it is showing, okay, it's mounted and it's able to access through network. Okay, so it is having star, so means in this network, anywhere if you go and check show mount -e and the NFS or IP, then there it will show this NFS share. Okay, so for testing purpose, what I'll do, manually, first of all, directly to go and execute these three files. Okay, so first of all, I want to mount manually any of the worker node. Assume this is one of the Linux machine. Just I want to test it whether this is going to mount it here or not. Okay, then again I will unmount it, so that when I deploy this deployment, automatically the pod gets created. Then it will use this NFS mount and it will mount it. So first of all, manually I want to test it. So for that, I'll take one of the IP of any of the worker node. So let me take this one and log into it. CentOS. If any problems are there, we can solve it here. Then dynamically means when I'm deploying the NFS client provisioner, so easily it can go and mount it. Show mount -e and the IP address of the NFS server 172.31.48, 172.31.48, 251. Okay, it is not showing and it is waiting, and I'll try to mount it. Okay, let me open another session. Can anyone tell me why it is not trying to access NFS server? Now this is a command mount -t NFS 172.31.48.251, and this is a mount point. So where locally where you want to mount, let's say data, assume data. Okay, it is not going to mount. Can anyone tell me why? Hmm? Very simple, two reasons. One is, in this machine, you need to check NFS is running or not, and NFS service status. Okay, and second thing is, it's already available. Second thing is uh, port. The main important is port here. NFS server wherever you created, it's run on some ports. Okay, so that NFS server use some ports. If you want to see, okay, here netstat-ntlp. So this rpc dot mount it is using, right? These are NFS ports. Okay, so these ports should be accessible by the nodes wherever it is trying to access. So that's why what we need to do in the firewall of this, in the security group of this machine, I am going to give full access. Okay, if you see 111.328.21 RPC bind mount. So what I'm going to do here, this is a NFS server, right? Go to the security groups. Incoming rules, edit, add rule, all traffic. I'm giving all traffic for everyone and then save. Now go to the same worker node of one of the machine from cluster and try to access it. Now it is done, right? Now if you see here, it is from NFS server. This is the source. It is mounted. Okay, so it's working. So we resolved one issue was there, firewall port issue. We resolved it. It's mounting. Just you do unmount / data, then again it will be unmounted. Nothing is there now. Okay, just for testing purpose I've done this. Now I'll go to the master. Where is the master? So this is my master 387. Where is my master? This is my master. So here these are the 3 files are available. Now first only I need to modify nfs-deployment file. Why? Because here I need to define my NFS server IP address. So here NFS server IP address is 172.31.48.251, I think so. Is it correct? What is up? I'm giving private IP because these all are internals in the same subnet. That's why I'm giving 48.51 NFS server IP inside this. And what is the NFS path? Here I created. I need to give that path name. What is that? This is the one. In the configuration file, I'm giving this information. And same thing in the volume section also, we need to give NFS server IP. So 48.251 and then path. Okay, and this volume which is getting from the NFS server inside this NFS client provisioner container, how you want to mount, you need to define it here. This you can give anything. Okay, so inside when the containers get created, the pod is gets created, inside this path will be mounted on this one. Okay, so now let me save it and create it. kubectl create -f nfs-deployment -f rback and class. Unexpected arguments class.yaml seek will create -f. Okay, I did not give -f here. Okay, means we need to give this is a file, so I missed to give your file. So now whatever is in RBAC, it got created, cluster role binding, service account, everything. And in NFS deployment, this was the object deployment. And in class, this was the object storage class. And these all are related to RBAC, service account, cluster role binding. Okay, all are got created. kubectl get pods. You see here, NFS client provisioner is running. Okay, so now kubectl describe pod Now it started, and if you see volumes, NFS, it got it from the NFS. This is NFS server and this is the share. Okay, successfully it's mounted from the NFS server. Now what I'm going to do, I log into that pod, kubectl exec-it. This is the pod dffnh, and if you see, this is from the NFS server and it got mounted inside the container. So this is going to work as a gateway for the physical volume claims and PVs. Okay, so this is how we were trying to achieve. So now this has been created. So whenever I'm going to create a pod now, so that pod is going to be uh, or whenever I'm going to create a PVC, physical volume claim, then automatically PV gets created. Previously I was creating PV and then I was using that PV for one PVC, but now there will be no PVs. So what I'm going to do, I'll go to the, let me come out of this kubectl get PV, kubectl delete PV. Let me delete this. First of all, we need to delete the pod, then we can delete the this one. If we don't delete the pod, then this will not get deleted. So let me log into another session. So right now I'm in the master and I'm checking what are the existing PVs are available. kubectl get PV. See, they are getting terminated, let it be. So now what I'm going to do, there will be no PVs. I'm not going to create any PV. I will create a PVC. So for creating PVC also, I have a document in my docs repository. Okay, if you see this NFS provisioner, open it. This is a persistent volume claim. Okay, so there is no PVs as of now. They are got terminated, right? Now, same cd nfs-provisioner. I create a file called vi nfs pvc.yaml. So now if you go through this one, this is just a persistent volume claim I'm trying to create. There is no PVs there, automatically it should create, and this is storage class. You need to modify this one. Okay, if you give just manual, it will not work. Why? Because kubectl get storage class. This is the storage class we just created 4 minutes ago. Okay, NFS provisioner. So this name I need to give it here. We are telling persistent volume claim that use this storage class. So then only this will go and talk to the NFS. Otherwise, it will not create. Okay. So now what I'll do, NFS-PVC. This is the name of the storage class which we created. And then rewrite many or rewrite once you can give, and how much storage capacity you are expecting, 500 MB or 200 MB. Got created. And before that, where is our NFS server? Okay, this is our NFS server. So if you go to NFS, nothing is available in this directory, right? NFS share. Now again I'll go here and kubectl create-f nfs-pvc. I'm creating a physical volume claim now. kubectl get pvc. Okay, this is, see here, it is showing in the pending state, manage NFS storage, and this is the one. There is no volume is available as of now. What happened? So let me kubectl describe pvc. Kubectl describe provision failed. NFS client provisioner. Why failed to provision volume with storage class managed NF? So it could not able to create um, read-only file system. Oh, what was the cat etc export? It's a read-write file system. Read-writes in no root crash. So let me log into that wherever it got created. Kubectl get pods. Where is that? Here. Kubectl get pods. And the gateway I'm logging in. It's cd. Okay, that is a problem. What are the file system we mounted? It is mounted as a read-only file system. That's why this is not allowing to create a persistent volume. Those are the Linux guys, they can easily understand. The file system can be read-only and read-write. So here, this one. So this has been mounted here, right? Under this file system as in persistent volumes. So here directories gets created when you create a PVC, the PV get created from here. But here it is not allowing to create any files. That's why PV is failing to create. Means there is something problem from NFS server to here. There may be issues. Okay. Give full permissions. So do we need to give nobody, change owner? Maybe that is the case. Let me see in my previous mission how it I provided in this mission. Cat etc exports. Oh, there is a no space between star and this one. Okay, so that is a mistake maybe I'm doing. That's why it's not able to mount it properly. So where is my NFS server? See here, I gave star space. Okay, so let me do one thing. Let me remove this. These are the options I'm giving. Okay, now service NFS restart. Now it's restarted perfect. Okay, previously it was giving errors because the wrong entry. And show mount -e it is showing. And so better again we can redeploy deployment.yaml file. Okay, means or else service NFS. To apply the changes, this pod I'm going to create once again. Okay, So what I'm going to do, I deleted the pod, and I'm going to use this NFS deployment once again. kubectl create -f nfs deployment. Oh, this is get kubectl delete deployment. Now again I'm going to create it. Okay, so now kubectl get pods. Now let me log into this pod, kubectl execute -it. It is mounted. Now let me see whether I can able to create files or not inside this one. Yes, I can able to create files. Okay, see, this is also by default showing one directory.